Good morning. This is a talk that I crafted as a result, basically, of me thinking about what can I still add to conferences after 40 years, more than 40 years of programming, and lots of interesting talks. I look at the program this morning, and there's actually lots of talks that I would like to see. Even slots where there's multiple talks that I actually want to see. So that's going to be tough. So I thought, well, you know what I'll do is I'll make it about my own journey. So this is a talk that sort of shows where I went in the past, like say 45 years of writing code, and it's been quite a journey. So the two things I love most in life are traveling and writing beautiful code. Usually I have the ability to combine it, which is quite nice. If you go to conferences, you get asked, and you can go to nice places like Athens or Manila, or so you can combine that with lots of traveling, right? So for me, that has always been something that they both inspire me to do the things I do, and I both hope to be able to do them for a very, very long time. And I found this sort of definition about what it makes that a traveling it's such a fully experience for me, right? So, and I found this definition called a travelist. It's for those who wander for wonder to fully experience a new locale. The culture, the people, the approaches to the everyday common task we all endure, to learn to be inspired, to deepen the soul, enlighten the spirit, and refreshen the mind. Now, that's a mouthful, basically, but it sort of describes what I feel when I travel. When I get out of an airplane and I step into a different air, different smells, different climate, different people, different cities, and that's just nice, right? I love doing that. And with writing code, it's actually pretty much the same. And my journey in writing code has been a very long one. I'm an old guy that you can all see right away, but it started here. This is the manual of my dad's pocket calculator, which he bought a long, long time ago. And I'll show you when he bought it, actually, because he was a very meticulous guy. He was a mathematician, right? So, and he bought his calculator basically because it could be programmed. And actually, it could be, well, it's in Dutch, sorry, the manual is in Dutch, and it's effortless programming. That would be cool, right? If we could do effortless programming. Have anybody who done effortless program? Nobody does that, right? We spend a lot of time in doing that. And this manual was actually quite precise in what you could do with it. And this is basically where I read my first lines of code from this manual. By the way, I learned to write code from books. You know, those are the things you can turn pages and stuff. And well, anyway, that was good. And then I figured out, because I recently found this manual, that's when I took the pictures about a year ago in my mom's house, and my dad wrote in it when he bought it. So this was September 24, 1977. So my programming career must have started somewhere like 1978. Right? That is before Java, by the way. And so Java wasn't the first language I learned. It was one of the languages I did the most, but not the first. So it's a long journey. So you might as well say, next to being a travelist, I'm a codist too. So it's the same definition, basically. And it applies to development as well, right? Those who code to fully experience a new locale. In my case, it's an LNL. The culture, the people, the approaches to the everyday common task we all endure, to learn to be inspired, deepen the soul, enlighten the spirit, and refreshen the mind. Because that's what I basically do when I write code. And I can do it all day long, basically. And I do that a lot. And I started wondering myself what this is all about. Why, for me, writing code is it's a nice thing to do. And it started with the great programmer Aristotle. I was in Athens 2 weeks ago, so that's you put Aristotle in there. He has a beard, so he must be a programmer. And he said, well, basically for the things we have to learn, before we can do them, we learn by doing them, which basically means just start doing stuff. And figure it out. And if you look at Japanese martial arts, they say something like this. They say, well, first you learn from a master. This is where the Karate Kid comes in, right? He's like wax on, wax off. I never know which way it is. I should look it up again. But he learns these things, so he has it in his muscle memory. And he learns from somebody who's done this before. And that's what probably goes for most of us. And then you learn to figure out when these rules actually apply and when maybe you shouldn't apply them. And in the end, you start to detach. You start to transcend from what you do. And this is basically where the Zen of Programming comes in. Because if you look at the definition of Zen, it says it is a state of calm attentiveness in which one's actions are guided by intuition. And that is basically how I write code these days. And that is I think my main thought when I wrote this talk is, every time I write code, and I write code with my team, and I do that every day, all the time, we sometimes have the discussions, should we do it this way or this way? And I'm like, let's do it that way. And then one of my colleagues might say, no, we're going to try the other one first. I'm like, okay. And then he tries that, or she tries that, and after like 5 or 10 minutes, he's like, oh, maybe you're right. We should have done it that way. And I'm like, see? And I didn't even try it, and I have no idea why that is that you see that. It might be experience, or maybe it's a little bit talent as well, but it's mostly intuition. And that intuition is, for me, is really, really cool. And then the question is, how does learning really work? And to do that, I'm going to have a look at a book called Becoming a Technical Leader by Gerald Weinberg. And Gerald Weinberg, in his book, describes how he was trying to learn pinball. Have you ever played pinball? Nobody. We have pinball machines in Belgium, right? I know, I've seen them. I've played on them. And well, he started to go to his local cafe and try to figure out how to do pinball. And he thought it would be a linear line. And when he was doing this, he realized it was not a linear line at all. There were moments when all of a sudden he got a lot better. And he started wondering himself where those moments came from. And he started jotting down the scores, and he realized that there were points where the scores went down, which is kind of peculiar. And then he figured out that that results from experimentation. At some point, you're like at this level, and you say, okay, yeah, I can learn a little bit, but I want to do something else. I want to break out what I do now. And if I break out what I do now, the only way to do that is by trying out some new stuff. In his example, he tried multi-ball. Multi-ball is pretty hard on pinball machines, right? You get 4 or 5 balls into play at the same time, and you try to keep them all in play. And what happens, and it happened to me as well, is that I played a lot of pinball in my time, and is that all of a sudden they're all gone. And you're like, what? Where did they go? And he tried an experiment. He said, what if I keep my eye on one of those balls, and the other ones, when they pass by, I'll flipper them away, but if they go, they go. But the one ball I need to keep in play, because then the play continues. And that was a smart move, and he started trying that out, and his scores improved. By the way, I actually tried this technique out. It actually works. I actually played pinball on a machine about a year ago, and I used this technique, and I got the all-time high score on the machine. I never was that good at pinball. So he realized that in order to get a lot better all of a sudden, he needed to experiment. And it's about those, let's say, experiments and the epiphanies that come from it that make you better as a programmer. By the way, it's not just learning, it's also unlearning. I find this really nice chart on the internet. I have no idea who the original source is, but I really like this chart. And this is me, right? When I was starting to write code, I wrote super simple code because I didn't know any better. And then I got introduced to OOP, basically, and OOA and OOD, and I added design patterns and lots of abstractions. And at some point in time, I was working for large financial institutions and rewrote software with at least 11 layers in it. Why? Well, because we could, basically, right? And when I left large consultancies, I stopped working for large consultancies about a decade ago, and I went to work for smaller companies, and then I realized I couldn't do all that stuff. I didn't need all that stuff, actually. And my mind started to shift towards writing code in a much simpler way than it was before. And that journey, I think, I'm assuming that most of us will travel this journey. And it doesn't matter where you are on this line or where you think you are on this line, it's all good, right? There's nothing wrong about the complex code, it's just slower. It takes longer to maintain, it's more expensive. But then again, if you work for a large bank, they have more money too, right? So in small companies, you need to write simpler code. So we started doing that. So I went out onto, let's say, a quest to write the super simplest code that I could write. And that's basically it. And that's been my journey of quite a long time. So this might be a good idea to introduce myself a little bit. My name is Sander. I'm on the stage somewhere here in this picture. This is in Athens 2 weeks ago. I'm a dad of 3, of which 1.5 live in my house. The third one is a drummer, so he lives somewhere else. He's a professional drummer, so he makes a lot of noise. I speak a bit, I write a bit, I travel a bit. I consider myself a serial CTO. Currently, I do that for a company called iBut, which is also active in Belgium, by the way. And I'm basically a lifelong programmer. That's what I love to do the most. About iBut, a little bit about iBut. This is iBut. We actually won. That was in November last year. We were at this gala, and all of a sudden, in the end, we became Website of the Year. I had no idea, so I asked the CEO whether we paid for it. He didn't know it either. Well, not that we paid for it, but he didn't know that we would become the Website of the Year. So that was nice because we just turned around everything in IT that we have. So it was like, I was really surprised by this. So this is me, by the way, just to prove to you that I'm a programmer. I am actually double object-oriented. Yeah, so I'm a programmer from birth. It gets worse because I live in the Javastraat. In Amsterdam, I actually did that on purpose. I actually wanted to live there because it's a Javastraat, of course, right? So, and I also write an open source framework, but that's in TypeScript. We've been doing TypeScript for quite a while with my team, so that's me. So, let's see, what's in this quest? So I tried to figure out what all of these epiphanies were that I had in my life. And there's actually quite a whole line. Maybe I should write it down at some point in time. And the first realization that I had is, already as a young programmer, is that you're never there. There's always more to learn. This industry is so big, it's the biggest there is, basically. So there's always more to learn. And that's not about learning the new version of a framework or a language, but it's also about the tiny little things that make your code more like, I like this better than that it was this morning. I read a tweet this morning. Somebody said, if you look at your code from 5 years back and you still like it, you haven't learned anything. I should put that quote in the deck, I suppose. But that was a nice, that's basically what it is. And I learned already in my first consultancy gig for my first mentor that what programming was all about. And he said, imagine that you're walking in a desert, in a thick fog, so you don't see anything, like this far before your eyes. There might be a wall in the desert. You don't know that. But it could be that there is no wall, and you're walking, and at some point in time, you might bump into that wall. That's programming. Right? It is, you're writing your code, it's all fine, and at some point in time, it doesn't work anymore. And you have no idea why. And you need to figure that out. And you need to step up to solve it at a level that you haven't been to before. That is what very frequently happens when you're a programmer. And Donald Rumsfeld put it really nicely. He says, well, basically, there's the known knowns. That's the stuff we all know we know. And there's also the known unknowns. That is the stuff we know we don't know, right? We know we need to, what did we do earlier this week? Reset the load balancer and make sure that some parts of the paths are gone. And we know that we would run into trouble because, well, we sort of redirected all the URLs to somewhere else and we forgot some paths. We knew we would forget some paths, right? That's okay. We all knew that. We talked to the managers who said, well, listen, we're going to do this, we need to do this, but we'll forget some stuff. And I said, can't you not forget this stuff? And we said, no, because we don't know where it's hit. We do know we're going to hit this. This is the wall that you know there is. The worst part is these are the unknown unknowns. That is the stuff you don't know you don't know. And as Rumsfeld says, if you look throughout history, it's the latter category that tends to be the difficult ones. So if you don't know that you don't know stuff, you cannot prepare for it. That means all these discussions about, yes, I know, but I want to measure. When is the project done, right? How long are you going to take to do this task? And the answer is, you don't really know. Because you run into the unknown unknowns. Not always, but quite a lot. And you have to figure out how to get around it. It also marks what I'm concerned, the end of productivity. Because we don't build 2 software or 3 software just like people build cars, right? It's not like, okay, today we're going to produce 2 cars. They're not all the same. Every puzzle we solve is different. And because every puzzle is different, we don't always know how to solve it. And if you don't know how to solve it, all these discussions about the productivity should really be gone. Also, because most of the code that you write is not written on the keyboard. Yes, you do need to do some typing, or you let ChatGPT do it for you, or Copilot in my case, but the code is written here, right? I have a bit of code running all the time in the back of my head. I'm actually trying to build the new frequently asked questions page right now in the back of my head. It doesn't compile yet, but I'll get it done somewhere today probably, or maybe tonight after some beers, or back in the car. It could happen at all points in time, right? So here's the thing. And Ken Beck actually said it really wisely. He said, at a conference I was in 2003, he said, well, I'm not going to refactor the code just yet, because the code doesn't know yet where it wants to go. And it took me a very long time to realize what he meant by that, like years and years. And eventually I got to the point that I'm doing this too, that I'm just, if the code doesn't really, I cannot get my hands around the code, I don't know how to do this, I'm just going to let it go. And I say that to the people in my team, oh, go do some other stuff, right? Go have a walk. Go to the zoo with your kids. Go to the swimming pool. Take a short holiday even, right? It doesn't matter. You'll come back to it. And when you come back to it, you realize that you found a solution somewhere in the back of your head while doing the dishes or doing the garden or whatever you do. And that is what's so cool about programming. Also, you come to the realization, of course, if you see this, that programming doesn't really fit in time boxes. It also doesn't really fit in 9 to 5. Because, well, if you look at what managers think that we do, they think we come in, absorb some coffee, have a stand-up, which they find awful usually, and then work until 12, go have lunch, come back, work from 1 to 6, done. There's people who actually can do this, right? I cannot. For me, it works like the blue line, right? I get my ideas while I'm in the shower, while I'm watching TV even, or when I'm in my car on my way to work, in the train, in an airplane, whatever, right? It can come to you at all points in time, basically. So, as a result, shall I stamp the stage or something, or kick something? I'm not sure what happens now, but there it's back. I need to stay like this, right? Doesn't help either. So anyway, in order to be able to do this programming stuff, that means your head needs to be clear. I cannot do work if I have too much other stuff on my mind. And then I learned, basically from a guy called Alistair Coburn, who said, he was in my car, we were after some conference driving somewhere, and he said, well, I always travel light. I had no idea what he meant. And I learned that over time, that the less stuff is in your head, the better your code gets. By the way, that also goes for other problems you need to solve, but it also goes for code. So I always try to make sure that I stay away from complexity as much as I can. And Neil puts it very interestingly. Oh, the screen's gone. Da, da, da. Different adapter, I suppose. There's Neil again, I hope. Well, it is on my screen. There's Neil again. So I totally adhere to what Neil says. He says, developers are drawn to complexity like moth to a flame, and often with the same result. Right? We burn ourselves in complexity, and we do that all the time. Every one of you has done it. Me, I have done it multiple times, because I'm an old guy, right? So, and Gregor puts it even better. He says, excessive complexity is nature's punishment for organizations that are unable to make decisions. Think about that when you go back to work, right? Think about, where people didn't make decisions, where companies don't make decisions, and you add another layer of complexity, another layer of abstraction to it. And at some point in time, you get to the top of the chart. And it's for you to figure out whether you are already on top of this chart, or are you already on the way back? And that's a complex question. And what we all seem to do and there's literally no exception, everybody in our industry does this, is we optimize too prematurely. Let me show you some quotes. Like we say, we might need this in the future, or eventually we'll need this. Or if I write my code a little bit more generic now, we can benefit from that later. Or, you know what, at some point in time, we're going to replace this database by another one. So I'll write my code, my ORM code, just to make it fit so we can actually replace the database by another database later. Who's ever done that? I suppose it's in Belgium, that's more than in the rest of the world, but I've done it once in 40 years, right? And that means I have put in the 40 years that I'm doing this, a lot of code into production just to be able to, at some point, replace the database. What's the point in that? Why do we do that? And I think I started to pay attention to words like this, like might and in the future and eventually and later, what if, and at some point in time. And the basic answer to these words should be, we shouldn't be doing this. Because we do a lot of unnecessary optimization, and we add complexity to our code where we just don't need it yet, right? And that word yet is so important because, well, basically, you can spend your time only once. I'm going ahead a little bit on the slides. That means you need to solve the right problems. If you don't have a scalability issue, don't solve it, right? We started doing microservices in 2014 at an insurance company. The first service we wrote, and we deployed it, a single instance on a single JBoss container, written in Java. We hit it. It could hit 68,000 logins per minute. And I was like, okay, I don't think we have a scalability issue here. So we stopped worrying about scalability. We didn't have that issue. You're not all Netflix, unless you are Netflix, of course, but in that case, yes, you do have a scalability issue. Or you're like Amazon, you go back to monoliths just because you have a scalability issue. But the problem is, you basically can only spend your time once. That means you need to be really, really careful. That doesn't only go for programming, it goes for your whole life. You can only spend all the time in your life once. So you need to figure out, what do you do with that time? I, for instance, stopped going to meetings. For the majority. I have 2 meetings per week. As the CTO of an e-commerce company, that's a good accomplishment, right? And I can literally spend the rest of the time working with the team. So the question that my team, there we go again, that we always ask when we try to do something is, do we really need this now? Or to put more emphasis on it, do we really need this now? And if we don't, we just don't do it. And that is, it saves a lot of time, it saves a lot of energy, it saves a lot of complexity. And we started to favor simplicity because there's a simple reason for that. And code is cost. Code is not a product, right? As I said, there's no way that we can say we produce 2 software or even 2 user stories. Every line of code you write is cost. Because you need to write it, you need to test it, you need to design it, you need to maintain it for a very long time. It needs to run, so it costs money on the server, money in the cloud, everywhere, right? So basically, the less code you write, the better it is. So all the code that we write in our team, if somebody else looks at it, we don't do peer reviews, but whenever I get my hands on a piece of code, and I'm like, intuitively, there we go again, intuition, it's okay, but it could be better, I'll do that, right? And the good thing is, if you have tests for everything, you can actually start doing this. So we say simpler is always better. And if we can make it more simple, it's better, because all the code that you don't write, you don't have to maintain. And that is a really big win. So I resolved to, actually, I changed the way I write code, and it's too bad that I can't do the monad part in this talk right now, but I started reinvesting how I write code. And I went to writing single-line functions, lambdas or single-line functions, or even classes that have all their functions expressed in a single line. And each of these lines executes on a single responsibility. Right? That doesn't only go for functions, classes, modules, microservices. It also goes for individual lines of code and simple functions. And I learned to start with the word return. Every function that I write starts with the word return. And I always do this, right? This is return. So what do I actually want to return? Okay, I want to return, what is it in this case? Some JSON that comes from some service. I need to do something with it, and then I figure it out. And that is sort of, it's reversing my train of thoughts on how to write a function. Normally you start writing, oh, I need to do all this stuff, and eventually I hope to get to the endpoint. And if you reverse it, it's actually becoming a very different way of thinking, which is really nice. And I started also changing the way I name things. This is a very nice, where is it from? Spring somewhere, right? So it's an abstract annotation config dispatcher servlet initializer. It's pretty precise, right? It's concise, it's good naming. But what a lot of people do is, when they put a parameter of this type in the signature of a function, they will actually name the variable the same, except that they put a lowercase a in front of it. And that makes your signatures extremely long. And there's no reason for that anymore, because we actually have good IDEs. I work with WebStorm and IntelliJ most of the time, and if I hover over a variable, I can see its type. I don't have to express that anymore in the code itself, in the naming of the variable. That used to be the case when we had simple text editors 40 years ago. That's where this habit comes from, right? And I started also not even naming them anymore after the type they have. So I have this, a comment gateway that is called comments. Oh, why? Because the rest of the code writes easier, right? It's comment repo find topic. I find it less readable than saying comments find topic, or profiles my, which is sort of like really, really short. But so I started shortening down things. And there's lots of things you can shorten that actually make your code more readable. So parameters don't get long value names. I don't name this variable JSON value with a small j. I just name it Q because, well, it's a query parameter. So that's what it is. So I name it like that, right? So also one last thing about this, well, it's the final last thing about this topic, is don't leave out commented out code, because it confuses the rest of the team. It even confuses you when you visit this code back 2 weeks later, and you're like, why is this code in there? Is that better, or should I still refactor that, or what's doing compared to it confuses. Kill it, right? Again, we have distributed version control systems. We don't need to leave commented out code in our repos, right? Just kill it. Just remove it. Whoever did it, like all the to-dos and all the stuff, just remove it, please. Also, by the way, if you write less code, your code becomes more secure by definition. So let's talk about architecture a little bit. So the main thing about architecture, I'm going to skip the slides with the big pictures here, because that's where it seems to be trembling. So Darwin, of course, a programmer, he has a long beard. He says, well, basically, well, I sort of refactored his statements, right? He says, it's not the stronger of the architectures that survive, nor the most complex one. It's the most adaptive ones, or most adaptable ones, the ones you can change, the ones you can take along with you over a long period of time. And I'll show you an example of that. Not to say that you need to follow my architecture, but just as an example. And Neil has also got a nice quote on this in one of his books. He says, an evolutionary architecture supports continual and incremental change as a first principle along multiple dimensions. I actually like this definition better, because this I can understand. I always need to, I saw Neil last week, but I forgot to ask him what he actually meant by this. But the thing is, an architecture that allows you to evolve over time and is still readable, still understandable, still buildable, is very useful. Now, I wrote this book about UML in 2003, I think, so that's 20 years old. And there's an architecture in that, and I'm still using that architecture. Again, not to say use my architecture, but to say evolve towards an architecture that you can use yourself, that is simple, that doesn't have 25 layers of abstraction, that doesn't need all these plugins and whatever you do just to make it work. And the architecture we use is very simple. It has a domain at heart, of course. So here's my entities, my value objects, my enums, all the stuff that goes in here, like, and every one of our services has this. And around it sits stuff like the repositories. This is still the domain. So I use repositories to get stuff from wherever it comes from and to push it back in there and to verify it and stuff like that. But typical repository pattern from DDD. On top of that, we use a layer that we call the process layer, where use cases are. And use cases come from the model, but they're also there in code. And they actually execute some process logic, if there is any. And on top of that, we have the endpoints. This is typical, the microservices variation of the architecture. And if you go out, underneath, you need to go towards whatever, a database, another service, some third-party software, a CRM system, Salesforce, wherever you go, right? An AWS bucket, but that's all in here. That's all in the gateways. So each one of these patterns has a single responsibility towards the whole architecture. And that makes it really applicable. It also makes it that it has grown along with me. This is a C# code base that I've recently found, and it has the same layers in there. If you look into these layers, it has the same type of classes, right? So to give you an example, this is a repository from a project I did in 2008, written in C#. And here's one in Java. It actually has tri-classes in it, so this is a functional type of Java. This is from a project that we did in 2015. And then there's another one. This is in Python. This is more recent. It looks very different, but it's still the same thing. And here's a recent one in TypeScript. So no matter what paradigm you follow, what languages you use, what frameworks you use, you can do something like this. Create a simple architecture and take it along with you. And for us, it's actually, it's sort of like we needed to do this because, well, we're doing microservices and we have, this is part of our GitLab repo list. And I think we by now have like 150 different small repos. If they would all have different architectures, we would be screwed because we're a team of 12 people working on all of this stuff. So we need to do this, right? So my tip is just do this, right? By the way, there's a description of this architecture on the website of the open source framework, but choose your own, right? Doesn't matter which one you choose. So to continue, actually, we come to the point that software development has gotten so complex that you were unable to build software on our own anymore, right? If you look into, I needed a React, a state management library for React. So I looked on the internet and I found this website that says, these are the 32 best state management libraries for React. And we're like, what do you mean there's 32? No, it's not 32. There's many more. These are just the 32 best state management libraries for React. There's many more. How do you choose from this? Or even solve problems where you don't have a choice yet. And that is why this framework comes in. This is the Cynefin framework. I'll explain it in like 2 minutes. But it's really worthwhile looking into this. So in the Cynefin framework, there's like a bunch of zones. So this is the clear zone. Now, in the clear zone, for every problem that's in the clear zone, there is a best practice. Simple example, if I have dishes on the sink, I'll put them in the dishwasher. I can wait until my kids do it, but they don't know where the dishwasher is. They're 27, 23, and 18, right? They have no idea what it is. So neither do they know where the washing machine is or that there's stairs, that you don't leave stuff on the stairs, etc., etc. But there's a best practice, right? So if you are in the complicated zone, that means that for every problem in this space, there's a set of practices that you could apply. And what you need to do is figure out which one fits best, make a choice, do some analysis, and implement it. This is basically still doable in a waterfall style. But on the other hand, if you go to the other side of the diagram, if you are either in complex or in chaotic zones, that means that there are no solutions to the problems you're trying to solve. At best, they are emerging. But emerging doesn't mean that you can just apply it, done, it's there, right? This is, if you have been for 40 years in a COBOL project and you still write the COBOL, you're still happy, you're probably not on the left side of the diagram. But for the majority of us, we are in the left side of this diagram. And if you are in the left side of this diagram, first of all, how do you recognize that? And second of all, what do you do with it? Well, it's easy to recognize because if you look at what Liz here says, she says, well, it starts from, we all know how to do this, which is basically clear zone, and it ends with, somebody's done this, but not in this context. Or nobody's done this before, right? When they went to the moon in 1968 and they needed to write software for that, they had no idea how to do that, which is pretty much the same as when you try to configure Kubernetes. Well, at least the same complexity, right? So when you are here, the only way out is by experimentation. And an experiment is a test done in order to learn something or to discover if something works or is true. That's basically it. So what you do is actually, you continuously need to do experimentations to get out of these complex and chaotic zones. And when there are no best practices, by the way, I think there are no best practices, there are merely good practices, right? And they're all valid within their own context. There is no universal truth out there. That means if you make a different choice than your colleagues, both of you can be right. Well, even at the same time, in parallel universes or whatever, right? So, and that's okay. But there's this stuff that's been going along with me for a long time. Like, well, you aim for high coupling and high cohesion. For low coupling and high cohesion, right? You don't want stuff coupled that shouldn't be coupled. You want the stuff that belongs together, sit together. It took me a long while to realize that wasn't the 1,300 repositories belonging together, because that's coupling. No, it was that I create vertical slices in everything I do, and that's cohesion, right? So that changed the way I wrote code. Or like the Unix philosophy, which is pretty much aimed at the same. They say, well, you write programs that do one thing and do that one thing well. Or the solid principles, they're under discussion, basically probably because of Bob Martin's political views, but one of the mindset patterns in is the principles actually says, well, it's a single responsibility principle. Every module should have responsibility over a single part of the functionality, right? Everything should do only one thing. Now, if I look at this Python code from my current client, this is a file with 352 lines of code. And I'm pretty convinced that I could simplify this code just by refactoring it and pulling it apart, removing the if statements, replace them by monadic code or whatever you could do. Or like this one, it uses 5 gateways in order to fulfill the functionality of this particular repository. And by it gets code like this. And even though it's just a few lines of code, I'm still confused to what it does. So I took it apart. This is code of one of my colleagues, and we took it apart. And that's a good thing, because making it simpler is better. And it's just by intuition, right? You look at it and you're like, well, 5 gateways to a repo? That's probably doing too many things at the same time. Let's pull it apart. Let's split it out into several repos and give them all their own gateways and see what happens. And then you see that the complexity sort of dissolves, basically. And that is really, really nice. So, testing. You all write unit tests, right? Yes, yes. Who doesn't? Nobody? Oh, that's proud. Thank you. That's really cool. So, so you should, by the way, right? So it looks a bit like this, right? You write some code, you write some unit tests, some of them fail, you make them work, done. That's the simple explanation to it. Now, the nice thing is about unit tests, they're the lowest level in your testing pyramid. That means if you can get that more or less complete to a large percentage of code coverage and branch coverage, that means that you can have some confidence in the code you write. But unit tests also run in isolation. And Michael puts it really right. He says, well, a unit test is not a unit test if it does any of these things, right? If you cannot run them in parallel, if you have 2,000 of these things, you don't want them to run them sequentially. You do want to run them in parallel, right? You don't want them to have to talk to a database, because that sort of gets you into trouble. Because if you put something on a database with your test and you forget to take it out, or the delete doesn't work, and you run the test the next time, it'll fail, right? So you don't want to do this. So you want to run it in isolation. Now, I see a lot in unit testing. I see most people do it by now, right? But most people, they start like this. They say, well, and this is conversations I had with one of my colleagues over the past year, I suppose. And she said, well, I just wrote all the code. Now I'm waiting for the business to test it. That's not really efficient, right? It's like it has this enormous feedback loop to where you are going. And then I said, well, you should test it yourself. And then she said, okay, I just wrote the code. This is the next time she came back to me. She says, now I only need to write the test. So people write their test after they write the code. And that's okay-ish. It kind of works. And I said, well, maybe you refactor it to smaller functions so you can test them easily. And she did. So he refactored it, all small parts of code, easier to test, and then she said, well, now I still need to write the tests. And that is what I call passive testing. And I think we can make much better use of testing when we try to see it as a design technique. And the design technique basically says, well, you try with the design to progressively eliminate the ambiguity in your code. And Dave Farley says, well, we should better start with assuming that the stuff is wrong instead of saying that it's right. A lot of my colleagues say, oh, this should work. And I said, how do you know? I'd say, well, I wrote the code and now it should work. And then we run it, it doesn't work, right? Of course, that happens all the time. So you basically, when you assume that stuff is wrong, you start by writing tests that go wrong. And if I look at my own test, this is what I usually do. This is my own test, by the way. And basically saying, I first write down everything that I could figure out that fails. And in the end, I write the test that makes it succeed. And that, again, is sort of turning around the way you write code. And that's what I call active testing. By the way, it gives you, if you do this, if you write all these tests, it gives you the confidence to actually change stuff. To change stuff even in the core of your libraries. And you can do that with confidence. And you can see, by the way, why he's praying, right? He's got his IDE in light mode. Who does that? This is actually, yeah, it's an actual picture, by the way. So, by the way, test code is code too. So there also it goes that the simpler it gets, the better it is. And you need to factor that out too, right? You need to refactor your test code too, because otherwise you'll end up in a place where you have nice code, but you have test code that is unmaintainable, still disallowing you to progress. So, next topic. Basically the last big topic, right? So this industry has gotten so complex, and the reason before, well, Dijkstra was right. He put this in 1986, I think, in one of his talks. He said, well, a programmer has to be able to think in terms of conceptual hierarchies that are much deeper than a single mind ever needed to face before. And that is tough, right? You cannot do that on your own anymore. If this is your stack, and you have 20 developers on the team, and this is a real situation from a client that I had before, my current client, this is terrible, right? It's going to kill you. It did, by the way. Company went bankrupt. Especially when you take into account the 90-90 rule. It says the first 90% of the code accounts for 90% of the development time. The remaining 10% of the code, well, it accounts for the other 90% of the time. Man, I love this one. So I came to the realization a long time ago that there's so much stuff that I really don't know. But the lucky thing is, the people on my team know it. When I'm here, right, I'm in this complex zone, so I have no idea where to go except for doing experiments. That means the only way you can do it is by creating your own stuff, evolving your own experiments. And it's typically like Alan, from my good friend Alan says, well, Agile is not a process. Agile is the ability to create your own process. And the same goes for the way you work in code. Figure out what works best for you, but make it small all the time and learn by doing it. Do these experiments. And the best way of doing that, I think, is doing it with a team. So actually, the team becomes the smallest unit of what you can do, right? It's not the individual. Do not talk about the individual, right? First law of software development is you don't talk about individuals. That's a bad quote. So this is my team. And we figured out a way to do stuff, to write code without all of this stuff, right? We don't do Scrum, we don't do Kanban, we have no sprints, no Scrum Master, we don't estimate, we don't use user stories, no retrospectives. We found a way of working that is still very, very agile, but has nothing to do with all of this. And that's okay, right? You need to figure it out for yourself. And the only thing we do is figure out what small problem do we have today. We actually like solving Rubik cubes. The guy on the left just won a game on it. He's really good at it. And we came to the realization that everything we do, if you look into small problems, requires different people from the bigger group. And that's fine, right? So you can change all the time with who you work, and we do that all the time. And we started calling it micro teams. We just pick a topic from the backlog, wherever it comes from. We form a small group of people, 1, 2, 3, maybe sometimes 4, do a mobbing. We discuss it, do the work, get it done, disband the team, and do the whole thing over again the next day. Some examples. So here's a developer and an ops guy sitting together looking at some Terraform. Here's 3 developers on my current team. They're looking at some really complex React code. You can see that from Francisco, who's looking really hazy. It's probably by the end of the afternoon, I guess. Or 2 developers and a tester. Of course, the tester has to stand. Yeah, you shouldn't become a tester, right? So that's it. So here's an architect and a developer. The architect is praying for it to work. The developer just knows it doesn't. And that's it, right? We work in these very, very small teams, solving little problems every day. Last topic. This is my mom on the left side. And Yeah, just to be sure, right? So, and we're at dinner, and I just got back from a trip to Italy, and then we traveled to Italy. I showed her all the pictures, and then she said, "Why did we, meaning my dad and her, never go to Italy?" And I said to her, "Well, you've been going to the same campsite in France for the last 25 years. And that's okay, right? There's nothing wrong with it. I've worked with developers who go to their office at 9 o'clock, write a lot of COBOL, or write a lot of Java, or C# or whatever they write, go back at 5 and are perfectly happy. They don't need to change. They want to evolve, right? They want to do the same thing all over again. We need loads of these people, right? But the thing is, if you are the one that wants to make the change, if you want to evolve, run these experiments, get out of your comfort zone, you cannot reread the last chapter. You have to figure out where you want to go. I'm a person that likes change, right? I like to do different things, new things, experience things. And that means I needed to get out to do this. And the basic thing is, if you want to change something in your life, in the way you code, there's only one person who can ignite that change. You cannot wait until your boss says that you're allowed to change. It's too late, right? You need to do it. You need to figure out if you want to use try code in your, or try classes in your code, just go out and do it, right? Experience. There's only one person who can ignite the change. That's you, right? So that means take small steps. Never be afraid of asking dumb questions. I ask dumb questions every day. I get dumb answers too, by the way, but no, also smart answers, but a lot of smart answers actually. And never stop learning. And probably the next two most important thing is never ever stop to have fun in this industry, because besides being the most complex industry there is, it's also the most fun industry to be in, right? That's why we're here. And the most important thing is, well, if all fails, then you just remove the node modules and you do an npm install, right? By the way, last thing, take your mom out to dinner more often. That was it. Thank you for indulging me. I have no idea if we went overtime because everything started bumping and squeezing. And so thank you for being here. And I hope you enjoyed the rest of the conference.